So if we want to draw deceleration, what do you know you have to do to those graphs for it to decelerate? It has to be the opposite. Good, Otanel. All right, so to decelerate, we just have to draw it opposite. So V and T, I just need to make it go down and down. Okay, it's just the opposite. Everybody good with that? All right, so the other three are word problems. So in number 2, what is the deceleration of a car? So for Markel, who is not here and is putting his phone away, all right, we have A equals VF minus VI over T. So when we look at the word problem, all right, it asks us to find VF and VI. So VF is final, VI is initial. Final just means the last speed, and initial means the first speed. So when we read this, it says 75 to rest. 75 is the first speed. Rest is the last speed. So this is VI, and this is V final. Rest is 0. Okay? So VI, 75, we're going to put in for the VI, and V final, we're going to put for VF and 0. Does that make sense? Okay? So VF will be 0. VI will be 75. And then the time is 2.5. Okay? Now, if you remember yesterday's discussion, what did I tell you all about deceleration? Deceleration is always what kind of number? Negative. Okay? So even if you flip the numbers and you did the numbers wrong, and I'll explain that in just a second. 75 divide, not that number, stupid. 2.5, you get 30. Okay, and our units will be miles per hour per second. Miles per hour over seconds. All right, when you subtract here, you get a negative. So you've got negative 30 for an answer. Every time you calculate deceleration is a negative answer. Now, let's say for a moment, Markel, when you did this, you said 75 minus 0 over 2.5, and you got positive 30. As long as you remember the question said deceleration and you know it's a negative answer, all you have to do is take your answer and put a negative sign on it, and you still have the same answer. As long as you remember, because it said deceleration is a negative number. That make sense? Okay. All right, so number 3. Number 3 says, what is velocity? So we're solving for velocity this time. All right, so what is velocity? Of a plane flying 450 miles an hour south into a headwind. What does a headwind mean? It's pushing towards the plane. So is it going the same direction or is it going opposite directions? Opposite. So what are we going to do to calculate it? You're going to subtract. So it's 450 minus 35. Okay, 450 minus 35. What is that, 415? 415 miles per hour. What direction did we have? South. All right, and the last one said, what is the velocity of bird droppings? Falling at a rate of 9.8 meters per second over 6 seconds. All right, so how do we solve this one? What y'all do here? Any ideas? Esau, what'd you do? Divide what? What formula did you think you should use? You use the formula, did you just do some math? Okay, so the velocity equals. Okay, a lot of people do that. Okay, so velocity equals d over t. All right, so if I pick that one, all right, I got a time right here. Do I have a distance? No. So this one will not work for us. All right. The question of the day is, what is this thing right here? Anybody know what that is? Anybody know what that is? Nigel? Nigel, what's that 9.8 meters per second? I said, what is this? Huh? Mm-hmm. What do you think it is, Jose? is acceleration. Okay? It's meters per second per second. It is acceleration. So, if that's acceleration, what formula should we pick? Nigel, be quiet. What formula should we pick? The what? Okay, so do we have two velocities we need to find? No, so what I say we should do to that if we're looking for V? Make it one. So get rid of that and make it one velocity. That's why I told you I like this formula, because it's asking you to find velocity, so you just need to make it one velocity. So your velocity is what we want, so you need to find A and T in the question. So what's our time? So we're going to put 6 in for that. What's our A? 9.8. So we're going to put 9.8 there. And now how do I find my V? Cross multiply. So 6 times 9.8. 58.8. And then one of the seconds cancels out and you get meters over seconds. Questions? Questions about how to do that? Derek, put your phone up. Please. All right. Can we move on, finish momentum, and then we'll do our lab? Okay. All right, so find your notes so we can talk about momentum, and then we're going to do our bubblegum lab. Or the tennis ball lab for Malik. All right, so we did momentum yesterday. We said the two things that affect momentum are what? What two things affect momentum? Mass and velocity, right? All right, we did that. So, one math problem, and then we're going to practice. We already did all that other stuff. Yes, Markel. Mass times velocity. Got your orange card? Okay, formula orange card. Ah. And finish it and stop talking.
I was just kind of like still like drifting off into the therapy.
Okay. All right, can we talk about how to do it?
Yeah.
All right, so what are we solving for? All right, what I give you? What's the key word in the question? These are all mixed up on the test. What's the key word, Nigel? What do you think the key word would be? Eduardo, what do you think the key word would be on the test? Don't shrug your shoulders at me. What do you think the key word would be? Okay. Now, when you look at it, all right, you really said velocity. All right, velocity is not a bad word. All right, but how many formulas do we have that have velocity in them? We've got, I said, what's the key word in the question? All right, you really said velocity. Velocity equals distance over time is one formula we have. We have A equals VF minus VI over T is another formula we have. And yesterday we learned P equals M times V. All right, those are the three formulas you have so far that have velocity in them. So if your rally says the key word is velocity, which one of those three do we want? Okay, so velocity is not the key word. What is the key word in the question that says to you, that's the formula I want? What? Momentum. Okay? Now, you could have said mass because you recognized it had velocity and it had mass. Okay? That's one thing. Or you could have said it had momentum in the question, which is how you knew I need the momentum formula. All right? Does that make sense? So, because it had momentum in it, that eliminates that one. It eliminates that one. All right? So, I would have said momentum is the key word like Nigel did. All right? Because it automatically says to me, I need this formula and wipes out the other two. So, if I need P equals M times V, which variable am I solving for? The mass, the momentum, or the velocity? I'm looking for mass. So, I'm looking for M, which means I got to have velocity and I got to have momentum. So, what is velocity is covered up there with that color. So, what is my velocity? So, I'm going to put 10 where V is. And what is my momentum? 50. So, to solve for my mass, I do what? What do I do to find my mass? I divide by 10. The mass is going to be 5. Now, if you look at your units, and you look here and here, what's going to cancel out? The M and the S are going to cancel out, and I'm left with what? Kilograms. Questions about that? Do you feel comfortable with that? All right, we're going to do a little practice with momentum, and then we're going to chew some gum. And calculate acceleration and deceleration. Or constant speed, possibly. So to figure out whether y'all accelerate or decelerate. All right, you need a calculator. You know, I'm glad Elizabeth brings enough food and feed you too. We ain't been friends. Okay, all right. Let's answer what you can before I stop. All right, this should move pretty quick. These are not very many questions. It looks like a lot, but it's not. I'm not going to get back with the sheet work. Hey. Yeah. They've already told me. I'm confused. What? What about? Oh, no. They all say something? Yes. I thought they were younger. No. Gosh. About? They all say 20. Calculate the momentum. That's a formula. Mass times velocity. Multiply mass times velocity. falls along after you find the momentum.
This one says 3.
I'm not 80.
What?
You can't do 2 to use those charts.
What do you mean short?
Calculator here. 0.04 times 2 is 0.08. Or is it more? You got to calculate all that. No.
We go through anything?
Yeah.
We turning it in?
No. We're going to go over it. I'm not giving you very long. If you have a question, just ask me. Call me over there. Can we look at what you come up with? Yes, done? Where we at? Okay. Let me see if I need a sheet where I have it in my thing. Put it there. All right. All right, so number one, you had to calculate some momentum. Now, the unit for momentum is long. You're gonna write all that crap down. See in the top where it says momentum, that says kilogram hyphen m over s. That's the unit. You gotta write all that stuff. So number one, next to the Blackbird, you have 0.08. Number two, the football player 100, the skier 900, bullet 2.4, and the frog 0.45. We go with that? All right. So number two, when I put them in order, I did not use the numbers. I used the actual labels. So from smallest to largest, I have the blackbird, the frog, the bullet, the football player, and the skier. All right. So number three, calculating the mass, I have 9 kilograms. So in number four, how does the momentum of A compare to the momentum of B? So I calculated A and I calculated B. So what was A's momentum? What was B's momentum? So what can you tell me? So, can the mass and velocity be the same? Yes. All right. So number 5, that's why I pulled this up. So number 5, it says, at what time did the ball have 0 momentum? Well, what time would the ball on this graph have 0 momentum? At 0, okay? 0 momentum is here, but what time are we at when we're at 0 momentum? We're at 0 time. All right, so describe this point in the ball's motion. Well, what do you know about the motion? It's what? It's not moving. Very good, Urali. Everybody good with that? Okay, and B, at what time did the ball have the greatest momentum? What was the peak momentum value? All right, so where's the greatest momentum at this point? Where would you tell me it's at? All right. At what time would it have the greatest momentum? Is that the same graph? Looks a little odd to me. I think I made something up here because that does not look like what I have on this paper. I made that up. Scratch that. Let me take this down and pull up the real graph. I was going to say, no, those numbers match what's on this paper. That was a good try on my part. Sometimes I've actually scanned them in and cut and pasted them and put them in my smart notebook, but that's just an extra I made apparently. So let me pull it up here so you got the same graph. I'm going to say, because none of those numbers look the same. There we go. Whoa, that might be too big. No, the graph's good. That might not have any room to write. All right, so the question says, at what time, oops, wrong one. At what time did the ball have the greatest momentum? So what time did we have the greatest momentum? Where on the graph would we have the greatest momentum? Way out here at the end, right? So at 2.5, we have the greatest momentum. And then it says, what was the peak momentum value? So here, so if we read over, what'd you come up with? 6.5. Everybody's good with that? Yes? No? Anybody not? All right, so the next question, C, what was the momentum of the ball at 1.25 seconds? So at 1.25, up here, we're going to have to estimate because we're sort of right there. And when we come across, let me get a pencil so I can point it down a little better. All right, so 1.25 is here. We go up, and so we're right there. Okay, so that's not really on a cross axis. So when we come across, we're going to be about there. So we're sort of between the 3 and the 3.5. So what do you want to estimate that at? If we're between 3 and 3.5, because this would be 3.5 here. 3.25, 3.5, 3.2. Okay, 3.2. All right, so our momentum will be 3.2. All right, so what's the ball speed? All right, so the speed is the same as velocity, right? So we're looking for V. Let me see if I can slide that over just a hair here. Okay, so we want to find the V because velocity is speed. That's what they're asking us to find. So how are we going to find that? What other piece is missing that we need? We need the mass. Did they tell us the mass somewhere? Where did they tell us the mass at? At the very top of the graph. Or in the very beginning of the question, either place. The 0.25. So 3.2 equals mass, which is, I gave us that dummy, 0.25, and then times V. So divide by 0.25, divide by 0.25, and then you can find velocity, which is, what did I get when I divided that? Somewhere around 13. Okay, questions about the last to see? Yes or no? Okay. All right, everybody feel okay about momentum? All right, let's talk to the lab. All right, let me grab a, I think I can erase that and reuse that one before. Grab a tennis ball, and then I got to grab the gun. For you, do not take it with you, lest you get in trouble in another class. Let me grab gum. That smell is, but it does not smell good. Where's the little stringy thing? All right. Who wants to be the outer of the gum? Nigel, come here. Come here. Give everybody their choice of gum. Except Malik. He's using a tennis ball. Mario, come here. Wake Mario up. Mario, come hand out the lab paper. Stretch your legs. Come hand out the lab paper. Yeah, you. You got to pick out a piece of gum and you need to stretch your legs. Bad when you dream you got hit.
I was taking my 30-second nap on the entire thing while writing up. See, look, I got this whole thing. I'd be like, I did this thing. No, I'm excited about it. No, I'm excited.
Thank you. What? Handing out paper?
Yeah.
Nice. Thank you so much. All right. So does everybody have a lab sheet?
Yeah.
Yes.
All right. So on your lab sheet, okay? Because yesterday or last night I graded papers for 2 hours. The last lab is graded. I need to hand those back to you so you can see what some people did wrong. All right. Some people lost 18 points on the last lab right here in this section. Tell me why they lost 18 points in this section. Then put a unit on anything. Okay? What unit do you think you should put here? What's it say right there?
It's a number.
Chomps. So your unit is going to be chomps. Now, a lot of people are like, Ms. Wall, can we abbreviate? Yes, write CH for all I care. Okay? Now, your time. What's your time unit going to be? Seconds. So when you calculate speed, what did I put here for the speed? It's the number of what? Number of chomps divided by time. Now, some of you are going to chomp, let's just say 30 times. So 30 divided by 30 seconds, because I tell you to use 30 seconds. So most of you are probably going to have more than 30, but let's say you chomp 34. I'm just making this up. Do not write it down. Let's say Miss Wall chomps 34 times in 30 seconds. Okay? Somebody divide 34 by 30 for me. Yeah. 1.13. All right, so my top line would look something like that. Now, chomps, seconds, chomps per second. I need a unit on all of that. Now, when I get done, we have trouble. Some of us have trouble with averaging. We take all 5 speeds and I divide by 5. You see how it says show work? I should see the math. I don't have to see you add, but I should see what all the speeds are divided by 5 equals and get an answer. Okay? Now, you're going to do this for 5 trials. Now, when you get down to this one you're doing for 1 minute. Okay, see how it says 1 minute? These are split times. So you're going to count for 1 solid minute. I'm going to let you use your phones rather than stopwatches. If you don't have a phone, let me know and I'll give you a stopwatch. So you're going to time yourself for 1 minute. At 20, write down the number of chomps that you have. Do not stop counting. Keep the count going. At 40, write down how many chomps you have. Keep counting. Do not stop. At 60 seconds, you can stop. You can stop because it will be in a minute and write down the total number of chomps you had. Okay? So you're going to run the full minute. You're not going to stop counting. You're going to write down the number of chews you had at 20, the number of chews you had at 40, and the number you had at 60. But it'll be a running total that's increasing the whole time. The leap for you is just going to be number of bounces, okay, instead of chews. Okay? You're just going to bounce the tennis ball on the floor. Okay? Now, then you're going to do the math calculations to go with it. Okay? Everybody's doing their own. You can ask people for help. Make sure you're doing it right. You can ask me. But everybody's chewing their own gum, and everybody's doing their own calculations. Now, you can chew your gum and start chewing it now. Please put the wrapper in the trash can, not the floor. And you need to get the gum soft and chewable before you start timing yourself. Okay? Instead of counting your chomps down while you're trying to get the gum soft. Everybody understand? Okay. And you will probably need to stand up somewhere to do that.
So the time for each of them during the first one is just 30 seconds?
Just 30 seconds. Correct. Does anybody need a stopwatch? Or do we all have phones? I'm not sure what's ever happened.
So what are we supposed to do?
I know you didn't go fast enough.
It was a joke. Chill out.
Why are you setting a timer? Why are you in stopwatch?
We do it anyway, well.
Interrupting my show down like 3 times.
Add them all up and divide them up. And do it with number one. What?
Just those.
Just speed.
Just speed for number one. And do those things have units on them? Uh-huh. So you're going to take all of these, add them up, and about the five. Yeah, you want chomping speed.
All the speed.
Gotcha. You gotta show me the work, so write down all that stuff. Okay. Okay, check. Okay, did you show me you divided? All for the same work.
Right.
Okay. I see, what are you asking me? Which question? So if that's your chomping speed per 1 second, what's your chomping speed in minutes? I mean, seconds or a minute? So what do you do?
Two more.
5?
No.
Is that how many seconds or a minute? Mm-hmm. Well, the seconds will do what? This is seconds, and that's chomps per second. So the seconds will do what? Mhm. This is seconds. And this is chomps per second. What's going to happen to the seconds? Yes, so you're left with what? Yes. Well, come on. Nope, you have to put all of these, which I need to see the work. You add all those up to get that number? You need to show me that.
Yeah.
Okay. You need to say 146 plus 143 plus 1. Just go back and do that in a minute. Are you talking about number 2? How many seconds or a minute? Okay, so that's your speed per 1 second. What would you do with this one if I wanted to know your speed in 60 seconds? Not bad. Mm-hmm. What did you just find in number 1? You found your speed in 1 second. So this is your speed in, yeah. And that'll tell you your number of chomps in 60 seconds. Yep. All right, so put your 30 there and calculate your speed. Put your 56 over 40 here and calculate your speed. Put your 70 over 60 here and calculate your speed.
Oh, okay.
Calculate your speed. Remember, if you have a question, just bring it to me. They pay me for. I'll sit there and not know what you're doing. Now you gotta calculate acceleration and deceleration, which is the rate of change. So you're going to use. Remember, you got 2 times. What do you do anytime you have 2 times? So you're going to subtract these. It's going to go on the bottom. You're using your A equals VF minus EI over T. So you're going to subtract those. Now you need the speeds that go with them. So the one that goes with 40 is this one. And the one that goes with 20 is this one. You're going to plug them in. So you've got 40 minus 20. One that goes with 40 is 1.4. And one that goes with calculate. You can do the same thing there. Okay? I don't care. And it's decelerate. Did you slow down?
Yeah.
No, I'm asking, did you slow down? Look at your numbers. Anybody else have a question?
They probably have us to like add everything up and divide it by 1.
Yes. Yes, I don't want a fraction. Yes, Isaac.
I do my work.
What work?
What I mean,
Did you go to ISS?
yeah, I ain't come to school with it.
It's in ISS. All right, so now you're going to take, all right, because you have These are your speeds, right? So, because you're calculating acceleration, VF minus VI x over t, you know you subtract, right? The 2 times, taking 40 minus 20. You know, you need the corresponding speed. So the speed goes with the 40 at 1.32, so I love that one. And then minus what speed goes with the 20. Yep. And you're going to do the same thing when you get here. Okay? Just do what? Other than you need to flip this because you do 60 minus 40, so it'd be 1.16 minus 1.4.
I got you.
Technically, it's an all order. Okay.
That's okay, I am.
Sure, it's negative. Okay. You just want the work to match. Remember, I'm an all about the work kind of girl, not just the answer. If I wanted just the answer, I'd give me a multiple choice lab. You know I'm not about that. Trevor.
Yeah.
What do you do? Because I'm pretty sure when I said you could have your phone, it was time, not to play on.
I'm reading my log of my time. Got that one down. Actually, did one for lapping instead of actual like stopwatching. The lap stopwatch. It was measuring how fast I was
Write it
reading.
down fast. Get back to your life. What does it cost the speed? Did the speed stay the same the whole time you were chewing? Then tell me that and why. How do you know? That's all I'm asking is how do you know? If you say no, tell me how you know. So, where? Yep. Sure. Okay. All right. There was no graph where it was constant. It's constant what? Eddie's word after that. Okay. Little constant. And then was your chomping rate constant? Yes or no? And how did you know?
Yeah, because
Well, if it went down, I would say it's not constant. I would say you decelerate.
Yeah.
I mean, so you went from 1.7 to 1.3 to 1.25. I would say you decelerated.
Yeah.
All right, so let's look at your calculations. Let's see what you have here. All right, so when you look at this, all right, yeah, you can go wrong. Let's fix this. No, you just use the wrong number. All right, you use the chomps and not the speed because acceleration is the rate of change in velocity. You need to use the speed. So you want to use this number. So you want to use the 1.325 minus the 1.7. Here you want to use 1.25 minus the 1.325. Now go back and recalculate those, and then you can look at your rates to answer that question. Okay, that's my concept.
We have like two Multiply it.
By, how many seconds in a minute?
6. So
Yes.
multiply your average by 6.
Yes. In this section, and you know your accelerator. What did your numbers change?
Okay, I have a question. Right here.
Mhm.
So you know how we did right here, talks about 60. So do we count the speed I got?
All right, you take your 32 over 20 here. You use that. That's
Yes.
You just simply take 32 chunks over 20. It's not hard. I'll be up there, my desk. Give me that over there.
Okay, well.
You gotta draw it first. Okay, so 32 by 20 is 1.6.
Oh, so I did it from here or here.
Apparently. Okay, so now you got 62. And then you've got 89 over 60. Now let's go back and put so when you get to here and you want to find your acceleration, what do you do when you have 2 times?
Yeah. What, like, no, we looked.
What would you have to do? What have we been trying to say today? Each time you have 2 times to do what? What's the answer?
Subtract.
Yes. So we're gonna say 40 minus 20. Go put the seaweed back. It does look weird.
Wasabi flavor too, eat that. Yeah.
Somebody in my second period had it, and then she gave half of it away to people in second period who wanted to try. Alright, so now you need the speeds that go with each of these. So what was the speed at 40?
It was,
So we're gonna put 1.55 there, minus, what's the speed at 20?
it was.
We're gonna put 1.6.
Green. It's green.
Okay, and then do the same thing here, only do it for 40 to 60. Okay? No, you've got to stick with the second chart.
I'm not asking.
You're in part B, can't go back to part A, right? No. Yeah, you can leave it like that. Use this stuff, right? Yeah, then you're fine.
Right.
Yeah. Does it look like constant speed? They sort of have.
It's not your stopwatch.
What type of valve?
Well, I would say looking at it and the way you've labeled it, because you labeled by twice, did it. Is it truly constant speed? No. But given you labeled by twice, it's probably gonna be that way. I would say, if you stretch this graph out, it will not be constant speed. Okay, so it depends on whether you want to stretch the graph.
What's this one? That's supposed to be like that.
But choose, it's probably easier to do.
So when you say, acceleration.
Depends on what you, graph. I didn't specify, so you can choose the data you choose to graph, because that's to be part of the data. That's over there. That's the, stop there, down, yep. Oh, yeah, I told how you and Darren coming.
Pretty good, I'm almost done.
Okay.
Right.
I flipped the 40 and 20. Because it's changing velocity, you have to use your speeds, okay? It may, depends on your data, but you gotta use your speeds. Your speeds are these. So the 40 next to this one, 1.1, subtract the speed of 20, the speed at 20 is 1.5. Yours is gonna be almost constant. And then when you do this one, you're gonna use this speed and that speed. Does that make sense? Yeah, so you know a minute, so how many seconds per minute? So, that's your chunk for 1 second. So what you're gonna do with these chunks in 60 seconds? Close. Yeah. Yes. All right, Jose, what you got a question on? Come back.
No.
No, come back. Let's see what your question was. You hadn't had one. You got up, walked over here. All right, so you said 40 minus 20. That was 20, not that I can remember. Okay, so you got 20. All right, you said 1.22. All right, let's put the 1.22 over the 40. Okay, so 1.22 goes over the 40, minus the number with the 20 is the 1.3. Okay, so we're going to put the 1.3 right there with the 20. Okay, so when we get down here, you're going to have 60 minus the 40. And then you're going to match up these numbers with 60 and with 40 to calculate there. Does that make sense? Okay, you're almost there. People have access there, and somehow we will not here to do it on the left and right.
We put it on the chair? We put it on the chair.
It was constant.
Yeah, it would have been constant speed there.
I didn't say it was.
Right, so that was a no. So that's how you know it wasn't constant.
What's the other one?
Oh, yeah.
It wasn't going to start. No, your crap shouldn't have been started.
I know, but it's.
Mine didn't have my numbers.
I hope you grab one, Tron.
I mean, it's still good.
It's way.
Yeah,
Here's your test review sheet. I'll think about it. Start on it. You have one, Nigel has one. I don't know if anybody else has done. Somebody else has done over there. Who? One, Trevor. Okay, yours is gonna be really small, because yours is almost constant speed. So I'm not surprised yours is that small. Yeah, yours is gonna be very close. What is this? This is called a test review sheet. Oh. Okay, so now it's not straight, so what kind of?
I'm just messaging. So just either average. You know what I mean?
For what y'all are graphing there, yeah. You didn't choose to graph it in a way that would be acceleration.
Either constant or average.
No, not having my preference.
Your juicy fruit.
What about you? What kind of?
I mean, it's not supposed to curve, but it's just like. You should say the graph. You just let me have the rest of them.
You got enough for the class?
Oh,
Let's go.
it's constant and you're still.
This will be, you can enjoy this.
Do I have to go?
Okay, it's just not gonna expand because it's such a small number.
What are the,
The decimal 3 zeros and 5.
what are the amputated kids' parents get from Christmas?
What?
What are the amputated kids' parents get from Christmas? Nothing, you couldn't open it, I don't know. I know.
Okay.
You always open with dark jokes, that way when you tell the actual lighthearted jokes, people feel like they have to laugh. If they don't, if they laugh at the dark joke, then they go back. Like, I don't really care. I tell them, I don't care. I don't really care. Well, what happens? 4 legs in the morning, 2 legs in the afternoon, and 3 legs at night. The human.
Wait, what?
4 legs when it's a baby in the morning, two legs when it's adult in the afternoon, midlife, and then 3 legs in the evening when it's an old man with a cane.
Oh.
I don't know where I got a spider from. You're like, oh, spider. Yeah, Spider-Man has 2 legs, and he comes out.
What did I say?
2 legs.
Looks like I got my birthday on
Four to
it.
get back up.
When they use 3.
Well, you guys check your paper and make sure you get a review sheet from me.
Is this for tonight or for now?
For now, I'll tell you which ones you gotta do for tonight. Most is in
Okay.
This will be the first test I take.
And Markel, you left me a calculator. You left me yours.
Technically, we're calculating.
Okay, well, here, be nice to Markel and take this. Go put your calculator up, because clearly she doesn't like me.
That's great.
That's wonderful.
Wonderful.
Okay, you remember English?
Trevor, let's do some work.
The first part.
I'm be honest with y'all.
I was the first one done the lab.
That's great.
I'm gonna fall asleep if I stop talking.
Right now, just do as many as you can. I'll tell you what you got to do for tomorrow. Huh?
What you talking about? What are you talking about?
Question?
That's what I did. You're doing it right now. Is we're gonna finish it tomorrow?
We're gonna finish it tomorrow, but part of it we're gonna do for homework tonight, because we will not have time to do it all. Right there. Yes, but there. Okay, yeah, given your numbers, yes, then that is pretty close back. There's, it's half 27. Let's do 1 through 14 tonight.
You said 1 to what?
1 through 14.
Sorry, Teresa. There's nothing to
Yes, sir. Okay. Most people prep. Okay. So, if you want to do 5 across there. Make these smaller. Instead of doing that giant, we'll pick up 5. Need it for 1 person in 4. So the new stuff, we work on this, and then just do Monday. So study for your test and then finish that. That's doing this new stuff, and I don't have the copy made for the thing we're going to do. Probably to you.
Okay.
I can't remember yet. All right, any of you who have not finished the lab, and if you need to take it with you, you can do that and bring it to me tomorrow. Did everybody get the homework page?